Hello guys, welcome back to the channel. Today we are discussing a concept called consistent hashing. So let's get right into the video. So the very first question is, what problem does it solve? Why we need some other hashing called consistent hashing? Does our good old hashing doesn't help? So let's take an example and understand. So we have a distributed database servers over here, S1, S2, S3, okay, S3 and S4. What we do is we have these servers indexed, and what we do, we use function, we hash, we use a hash function, we hash the key and have it modulus by n, where what n over here is the number of server. This is what we do. So n is 4 in this case. So we hash the keys to hash the keys and do the modulus to know which server 0, 1, 2, 3, on which server the data needs to be stored. So this is what we do in the basic hashing what is. So now let's distribute some random keys, two random keys to these servers, to S3 and S4, and we have keys like K1, K4, K6, K7, K0, K. Okay, 1, 2, 3. Okay, this is what we have. So now what happens is, for some reason this S3 is failed. Now will this be the same as the n? What happens to the n? N is 3. Now we again rehash, use the hash function and again map, because we need to accommodate these. Now again things happen. Now something changes. For example, this happens. K5 it's there. K7, K0, K4, K5 it's there, and K4 goes there. Okay, this happens. Now we want, for example, K5. We want K5. What data was stored in K5? Some operation needs K5. Now, if you see K5, it's pointing to S2. But over here, K5 was there, and the server to which it was pointing to S4, it's still running. So this operation will not fetch us the right data, or this will need to get the data from here. That's very unnecessary steps. What only required was K0 and K4 accommodation. But what happened? Many keys got changed. Same with K6. Now it's pointing to S1. It will not have the data. So whenever the server fails, or we can say downscaling, or even if we upscale, deletion or insertion of the server will cause the remapping of these keys, and that is not good. It will cause a lot of overhead to get the data and all that. For example, you have a cache server, and that is distributed like this, and now the whole point of caching is just gone to waste. So now that's why this consistent hashing was introduced. So what is consistent hashing? So before getting into that, we need just 2 3 points to be discussed. First is hash function. Basically, what hash function does is you give some input, and it gives, after doing some algorithm, for example SHA, when we are using, or something else we are using, it just gives in the range of this x minus 1. You give the input, this hash function gives something in the range of x minus 1. This is what it does in layman terms, in easy words. And what is hash space is this only, this, the domain of hash function, domain of hash function. And what is hash ring? Hash ring, just join these two ends. So okay, x minus 1 0. So this is your hash ring. Okay, so now the foundation is done. So what happen is, in this hash ring, what we do, server using the hash function get some position and put it on this, or put on this hash ring. For example, now this is s1, randomly I'm just s4, this is s3, and this is what left, s2. Okay, same with the keys. With the hash function we get some position and we just plot them there. So let's take something like k0, k1, k3, k2. So what we do is we go clockwise and map these keys to these servers. So whenever we want some data that is stored for this k1 key, we will point to s2. We have to look to s2. Same k3, we will look for s4. This is what we do in consistent hashing. But now, why this is better? Why this is better? So let's see this. Let's take an example. Then you will understand. We have this hash ring, servers s1, s4, something s3, s. These are all representation. Just I am just representing. Just don't take it a rule or something. Understand the concept. Yeah. Mhm. Why I removed it? Just for easy explanation. Not as in that something else. So, key 0, key 1, key 2, key 3. So, for example, some case this S4 is no more here. So, what happens is, when there is downscaling, deletion of the server, so what happens is Whatever server present in the clockwise direction, next server, the key starts pointing to that. So it points to S2, S2, wrong color, S2. Okay. You can see over here these keys, all the keys still are pointing to the same thing. Only thing changed is K naught. So it is saving such hassle. What hassle? This of getting the data and all that. It is saving us from all that hassle. Just it points to the that next server clockwise. Get the data on that server. That's it. Nothing else. Same case is when you upscale or add a new system. Basically, we are doing horizontal scaling. Different color. Let's take example. If we delete is covered. If we add something, S1. Let's take a short example. S2. So this is the case. Now, if this new server is introduced, this new server is introduced, what happens is these all whatever key present on the left of it will start pointing to this. And if this is already present over here, so like if you see, if this new server is introduced, whatever present on the left of it will start pointing to this till this new server. Whatever is present over here will start pointing to this new server. Okay, this much is understood how we are doing it. And you can see this and this still remain the same. Only thing is these two are changed. This much is clear. So but there is one problem in this. What happens is, again, this circle thing, we had keys. I'm not writing key 1 key 2. Now you understand basic color coding I'm using. These keys were pointing to this and these were also pointing to this. This was the case. Name it whatever you want. These are keys. These are servers. So let me write S0, S1, S3. Okay. For some reason this S2 is deleted. S3 is deleted. This is deleted. Now what happens? All this just starts pointing to this. Is it not overloading this? Yeah, it's concentrating on just one server. That is also not good. So what we do is we introduce some concept called virtual node. So what happens is virtual servers are created. Let's make a diagram then. Understand S0, S0. They are distributed instead of just concentrated at one place. For example, over here, if you can see, S0 was just over here, but the instances are spread along this ring. Some S0 2, same as S1 not, S1 1 and some S1. So what happens is whatever key is present over here clockwise, it starts pointing to this. We know this much. This we already know. That's fine. We know. So what happens with this is if I mark it, so whatever in this region will map to is pointing to server S1. Whatever pointing to this region, in this region, is S0. Again, not S0, S1, sorry. No, no, S0. Sorry, my bad. This is the server that it's pointing to. You can see S0. So what server it is pointing to? S1. So this is S1 region. So this will point to what region? S0. This is pointing to S1 and this is pointing to S0. As you can see, the distribution you can see S1, S0, S1, S0, S1. Instead of this S0, S1, S2 at one place. Now they are distributed. So if this points to S0, so it S0 it's pointing to S0 server. S0 dash 2 it's pointing to S0 server. So this is what virtual nodes are. So I hope this consistent hashing is clear to you, and if it did add some value to you, so consider subscribing to the channel, liking this video, and you have to do what you have to do and keep grinding. You guys are awesome. See you in the next one. Bye bye.